So hey guys, welcome back to my channel. So in this video we are going to solve the problem of search in a sorted matrix. So we have to search a key in this sorted matrix. So how it is sorted? It is sorted from row wise and also it is sorted for column wise. Sorted. So 10 is less than 20, 30 is less than 20, 40 is less than 30. So the previous element is smaller than the further element. And in column wise, 15 is greater than 10 and 27 is greater than 15 and 32 is greater than 27. So it is sorted in row wise also and it is sorted in column wise also. So in this array or 2D array, we have to search a key. I've seen two types of algorithms to search an element in the array. So first is linear search and second is binary search. Previous video we have seen the linear search approach and binary search approach. So you can go and watch the both the videos in my YouTube channel. Let's think the approach to find the key in the matrix. Let's think about the approach. So the approach will be whatever first in the mind comes to solve this approach. So it's called as the brute force approach. Whatever in your mind comes first and applied in the code, it's called as the brute force approach. So we can go to each and every element. So int I is equal to 0 to n, and this is for row, and for int j is equal to 0 to n, and here we will give the condition if our array of I j equal to the target or key, so we have to return the true if the element is present in the matrix, and if the element is not present in the matrix, then we return false. Its time complexity will be big of n square. So its time complexity is very bad. So we need to find the optimized approach for finding the key in the 2D matrix. So let's think about the second approach. So it can be row wise. So it is sorted from row wise. So I have drawn the above matrix again, and suppose we have to search key in this 32. So we have to search 32 in this matrix. So we can apply the algorithms in row wise. So we can apply linear search also, or we can apply binary search also. So in linear search, the time complexity is big of n. So, and in binary search, the time complexity is log n. The binary search have better time complexity than the linear search. So we can apply here binary search algorithm and find our key or the targeted point. So if we apply the binary search here, we will not get our element. Okay, so in second row, if we apply the binary search, so in this row also we will not get our element. So in third row, if we apply our binary search algorithm, in this we will also not get our element. So in fourth row we will get our element. So its time complexity will be, so for binary search complexity is log n. For this matrix, the time complexity will be n log n. So we have to traverse n columns and we have to apply the binary search also. So its time complexity will be n into log n. So it is more optimized way to find the element than the brute force approach. So let's think our third approach here. If we start from this element, 10th element, okay, so and suppose the key is 33. In this, if we start from the 10th element, we do not have any concrete answer to reach till the key. So here we have the elements greater than 10 and here also we have the elements greater than 10. If we start from 50th position, okay, so we do not go in this side and we also do not go in this side, whether we have to go up or in left side. So here also we do not have any concrete answer whether we have to go to left to or whether we have to go to right to reach till the key, because in both the sides we have the smaller elements. Here 48 is smaller than 50 and here 39 is also smaller than 50. Okay, so if we start from 40th element, this position, so we cannot go here and we cannot also go in upside. So we have two positions, so we have to go to either left side or downside. Okay, and if we compare 40 element is greater than our key, so we have to move to left side because we have greater elements here and here we have lesser elements, and element is less than 33 our key, so we can move to left side. We can compare 30 element with our key, so 33 is greater than 30 to move to downside because in left side the elements are more smaller, so we have to move downside. Then again 35 will compare. 35 will compare with our key. So it is greater than our key. Then we have to move again left side because the elements are bigger in downside. So we have to move left side. So here we have 25 element. So it will 25 element will compare with our key. So 25 is less than our key. So we have to move then downside. And then it will compare with our key. So 29 is less than our key. Then we have to move downside again. And here we will found our key. So this is the most optimized approach to find a key in a sorted matrix. So what we have done, so if our key is less than cells value, then move to left side and if our key is greater than our cells value, then move to bottom side. So let's start with our demonstration. I have created a class called demo1 and in that I have created a main method. Now we will create an array here. So I have created a 2D array here. Now let's create a function public static return type will be boolean and here we have to pass our array as well as we have to take a key also here. So let's take key is equal to 50. So we have to also pass in this parameter key. So in this we have to create two variables, int row is equal to 0 and here we have to create another variable column and we have to initialize it by array of 0 dot length -1. Okay, then we have to run a while loop while row should less than array of length and column should be greater than 0 until that loop will be run. And if array of row and column equal to key, then we have find our then print if array of row and column are equal to key, then we have to print key found at row and column, means we have to give its index. Okay, so we will get our correct position of our key in the matrix. Now we have to return here true because we have taken the return type as boolean, so we have to return true here. And else if key is less than array of row and column, so we have to decrease our column, so we have to move to left side. Okay, and else if key is greater than our row and column, then we have to move to downside, so we have to increase our row. Okay, So we have to also return the false here, and here we have to print. So we have to print the not found. Okay, we have to return false because we have taken the return type as boolean. So we have created a function for finding the key. So let's call the function from the main method. So search, and here we have to pass our array, and so let's run the code and see what will the output. Okay, so we have get the location of our key is 3 and 3. Okay, so it is present on third row and third column. So it is here, it is 0 1 2 and third column. So 0 1 2 3 third column. So here it is present, and we have passed the key as 50. So we have get the exact location of our key. So if we change the key and let's take as 101, run the code again, we will get the output as not found because we do not have 101 in our matrix. So this way we can find our key. So thank you for watching this video.